to the last session for this training program. I understand it's been 3 long days where it's been packed with long sessions. This will be the last of it. So far, our experts have spoken at length about CCD in great detail over the last 3 days. And we have also discussed CCS and very particularly the capture aspect of CCS in great detail. However, CCS discussion would be incomplete without discussing the other 2 key aspects, which is transport and storage. So within the next hour, I will be taking you through transport and storage, or rather, each one of you will be taking all of us through these topics. I have a set of questions that I put up here. All of you all know the answers for all of these questions because you've been listening to the sessions over the last 3 days, and it's just a bit of, say, you could, like for example, when I say what are the possible modes of transporting CO2, just think about it for a minute, and any of you give me the answer. I'll put it down on the board here. Pipeline. Yeah, sure. I'll just give me 1 second. I'll brief you on the entire session and then we'll take off. So likewise, what we'll be doing is, you will be giving me the answers for all of these questions. So that ensures that you've had a quick recap of your understanding of transport and storage, and whatever gaps are there, we will bridge it through the PPT, because I prefer not to use too much of the PPT actually. So we'll start off with our first question. What are the possible modes of transporting CO2? Sure, sir. Pipeline. Anything else? What are the possible modes of transport are there for CO2?
Tankers.
Tankers. Excellent. Vessels. Any other perceivable mode of transport? Anything that comes to your mind?
Compressors.
Compressors for transport? We are specifically talking about carbon dioxide has been captured, it has been compressed, it needs to be transported to its storage site. So, is there anything else that can fit in here? Or you think this is alright? This is alright, okay. What are the factors to be kept in mind while designing transport media? Now, exactly, we all know that we need certain transport media. Pipelines, tankers, vessels. Now think about what aspects have to be kept in mind while designing. Number 1. Safety. Leakage will again form part of safety. Anything else?
Size.
So size, the pipe diameter and size.
Temperature should be maintained.
Temperature should be maintained.
What form? Liquid, gas,
That will be forms of transport. Okay, fine. You can say the form of carbon dioxide. Anything else?
Pipeline routing.
Okay. The layout. Pipeline routing. Anything else?
Selection of material.
Perfect. Selection of material. Actually, it's probably the primary aspect that you take into account when you are designing any transport solution, be it pipeline or vessels or your tankers. The material that is used to build the transport media. Right. Do you think anything else can go in here? Or you think it's alright? Cost is again, it is at this stage of CCS development not a very important factor. But yes, once CCS sets out on a big scale, cost will then become a parameter. And that's when, that comes at a much later stage. Still put down cost. Right? So this is okay? Move to question. What would be the possible implications of carbon dioxide transport? say you're laying pipelines or you're transporting via vessels or tankers. So what could be the possible implications of carbon dioxide transport? Okay. Safety aspects. Anything else? Any other possible
Quantity to be
implications?
transported.
Okay. Quantity to be transported.
Implications might be more release of emission.
How to transport? Storage is there, storage is transport.
Storage is obviously there. There is no question. Storage location is there. What I am asking you is, let me be a little more specific. The implications of transport on, say, other living beings on the earth. Or you could also say in terms of laying pipelines, for example, the routing of the pipeline, etc.
Layout is the implication. Backup system.
Backup systems. Alright, so this seems fine as of now? Okay. What we'll also do is we'll answer the other three questions as well on storage and then we'll go to the presentation. Again, so what do you think are the possible storage locations for captured CO2?
Depleted,
You are supposed to answer.
depleted things.
Depleted mines? Right, depleted mines.
Depleted oil mills.
Okay, depleted mines and oil wells. Underground.
Under the sea.
Right. Under the sea. Underground. Next one. Under the sea.
Space.
Space! This is a very, very innovative answer. So this is something that we really have to probably, the scientists of the world have to work on this often, I guess. Right, space. Anything else?
Limestone.
Limestone. Could you be a little more specific?
Not very sure what it is. Some mountains in US and Canada where they store them.
That's right. Limestone is. Limestone is.
Because it is converted to calcium carbonate.
We think so it could be stored over time. Just note it down. Limestone is. Any other possible storage locations for carbon dioxide?
Converting CO2 usable to fuel.
Okay. Converting to usable fuel. Any other possible storage locations where CO2 can be stored? Okay, that I think has been covered. Okay, fine, right? In other rocks, make a hyphen, right? Between the rocks. No. Between the rocks. Okay, and? When you say concrete bunkers, again, anything more specific? Are you talking about bunkers on land or are you talking about making bunkers under the surface of the road? Underground bunkers. Okay, we'll discuss this storage aspect in a little bit. The bunker concept is coming up. Yes, underground bunkers. Concrete bunkers. It's actually a good idea, but yeah, it will come under intermediate storage. Cannot be permanent storage option. It is an intermediate storage option, but it's not a permanent storage option. It is definitely a media because it is an option. You're right when you said that it's an option. Right? Okay. How do you think the storage site can be identified? Just wild guesses. I mean, none of us are geologists per se, but yes. Sorry? No. What I'm asking is, suppose you decide that you want to store CO2 in some depleted oil well or something, some other underground area. How do you identify such sites? Just your thoughts on it.
Life is not supported.
Okay, where life is not supported.
It's not in the
Exactly. Anything else?
Should not be international border.
Okay. And what are the, how can you select sites?
Proximity to the plant.
Okay. Proximity to plant. And
Like desert.
that is covered in area where light is not supported, etc. How do you know what is under the ground? Perfect. Satellite. Any other thoughts? Okay. The last question. What do you think the possible implications of large-scale storage of carbon dioxide? Implications of CO2 storage. Okay. Earthquake. And other natural hazard. Anything else? Okay. So what we'll then do is we'll quickly go over the presentation and see how much of it you have got yourself right. Because this is a great job. We've actually covered a lot of things comprehensively, which shows that you all have a very good understanding of what transportation and storage involves. That makes my job that much easier. So I'll quickly take you through a couple of slides and one or two good videos that we came across, so that helps you understand how the whole process happens. From Mazda that captures, that talks about capture.
Audio is not coming, but let us explain on this. This is from the Emirates Steel Plant in Abu Dhabi, where you have 6 million ton steel plant, which you can see on the violet color over there. And this portion is the DRI plant, direct reduction ion coming on. It's a gas-fired DRI where you get CO2, almost 95% pure CO2 is coming out. This CO2 is basically captured to the pipeline and then transported back. You can see the color over here. And this is the typical layout of the plant coming out. This is the CO2, this is the buffer tanks over there where we store CO2 and clean up the CO2, and after cleaning up and goes to the compressor house. And then from the compressor house it goes to the pipeline. Actually, in this particular video, we are following the pipeline.
Could be pipelines, which could be both on the surface and also under the sea, tankers and vessels. As of now, pipelines are most cost effective as far as large scale transportation of carbon dioxide is concerned. And as of now again, considering current practices, the transportation conditions for CO2, it is very similar to any hydrocarbon transportation condition. Again, CO2 theoretically can be transported in all three forms, gas, liquid and solid. As of today, again, solid, it is not practical for large-scale CCS because the amount of energy that is required for the solidification itself is very, very high. So it is not economically, again, viable for large-scale CCS. So solid transportation is theoretically possible, but it is not a very economical option. And yes, volume of transport can be reduced by transporting at very high pressures, and that's usually what is, as of now, done. Somebody spoke about the design aspect. Somebody said that the material that is used for, preparing the transport media is very, very important. To be more specific on this, carbon manganese steel is usually used to make pipelines for rice flow transportation, as it is not corrosive. Here it is important that the carbon dioxide that is transported is free of NOx and SOx. Again, because the presence of sulfur can result in corrosion of the pipelines, because most of these pipelines are made of, say, stainless steel or other forms of steel. So it's important that the carbon dioxide that is transported does not have any sulfur content or NOx in it. Coming to the construction aspect of, say, pipelines on land, before any project proponent can set out to, lay pipelines and start construction activities for CCS project, all legal permissions and all clearances must be in place before you can actually start putting up the pipeline. Because otherwise it results in right-of-way issues, and because land acquisition usually is a very big problem in case of laying pipelines on the land. Then usually the process is very similar to laying your hydrocarbon pipelines, as I said. Initially the trench is excavated, and usually they ensure that long lead time activities are done first. It is a very tricky part when you're trying to lay pipelines in densely populated areas or in river beds and small crossings, road crossings, etc. Because these are very critical areas, and hence they also take the longest amount of time. So these are activities that are completed first, and then peripheral areas are taken on. Usually, again, as I said, if you've noticed any pipeline construction on the roads, you must have realized that pipes of certain length are welded together and then they are laid in trenches. And usually what happens is, once the pipeline is tested, obviously to ensure that there is no leakage, etc. that's happening through it. Not just hydrostatic tests, a lot of other tests are carried out to ensure that there are no cracks in the pipeline, so that we can be sure that carbon dioxide will not escape through any possible means when the pipeline is then put beneath the ground. So once the pipeline is welded together, as in the sections of the pipeline are welded together, and it is placed in its trench, the trench is again, and it is sufficiently covered or insulated to ensure that there is no peripheral damage to it. The trenches are then filled, and in most areas, vegetation is again brought back on the location where the pipeline has been. So essentially, it is right beneath the ground, where patches of vegetation can be grown on top of it. There can be houses on top of it. It's quite possible. When it comes to underwater pipelines, I was trying to get a video of how it is laid, but unfortunately, YouTube is having problems. Again, this is again very, very similar to any normal pipeline construction that you must have, if you are aware of, as far as marine construction is concerned, where again the commonly used method is the lay barge method, where pipelines of smaller lengths are welded together on the shore and then taken on the barge, taken deep into the ocean, and then it is placed on the ocean bed. Here again, either it is directly placed on the ocean bed, or trenches are dug if the ocean, if the water level is shallow enough, the trenches are dug and it is placed on the trench. Suppose if it has to be placed deep in the ocean, the trenching happens after the placement of the pipeline. Coming to operation and maintenance, this is probably one of the most important aspects of CO2 transportation. Because a lot of responsibility lies in the operation and maintenance, because once the pipeline is laid, it is very, very essential to ensure that it is in good health at all points of time, and and doesn't pose any hazard for the people who are living around or in the same area the pipeline is located in. Because oftentimes it happens that these pipelines can be in very densely populated areas as well. So what happens is, the example that I put on in the slide is typically a case of what happens in the United States, where a lot of small CCS projects are already functional. So the norms are pretty much the same across the world. Like for example, the key is manpower training. People are specifically trained on how to handle these CO2 pipelines. Also, timely inspections are carried out after the initial laying of the pipeline. And there is a sequential process, and there are various approaches that are there to ensure that the inspections are carried out, and we are assured at all times of the fact that there is no leakage or no other hazard because of the pipeline. Like for example, the first point that I mentioned, pipelines are cleaned and inspected by piston-like devices driven along the line by gas pressure. These devices, they are called PIGs, P-I-G-S. It's a small battery-operated piston-like device which is inside the pipeline, inside the CO2 pipeline. So what happens is it moves along the length of the pipeline, and it has dual functions. First, it cleans the pipeline to ensure that there aren't any scaling, there isn't any scaling. And secondly, it also inspects the inner lining of the pipeline to ensure that there is no leakage or cracks that are happening or any unusual formations in the pipeline. Secondly, these pistons, as I said, are multifunctional. They can measure internal corrosion, mechanical deformation, external corrosion, and precise position of line where there could be some kind of faults, etc. Apart from this internal monitoring, there are two other ways of externally monitoring these pipelines. Now, what happens is these pipeline sites are usually marked, and the people who carry out the inspection operations are aware of where the markers are. And usually the general public is also made aware of regular markings as to where the pipeline lies approximately. So what happens is, keeping the public aware of where the pipeline is ensures that they don't do any unauthorized excavations or any construction on the area where there could be a pipeline or in areas where the pipeline is not out of the ground. So this again is for their own safety. Several programs, I think yesterday Shweta had shown one video where they had shown people explaining to the locals about these pipelines, then sensitizing them about the transport pipelines and what are the do's and don'ts as far as these pipelines are concerned, especially in areas where they are populated. Now, there are two ways of monitoring these pipelines from above the ground. First is, there are again battery operated, you can't call it a helicopter, it's a small probe-like thing which is again battery operated and it goes along the length of the pipeline. So these again work on infrared principle, wherein through infrared rays they detect for leakages and possible sources of deformation or any unnatural activity as far as the pipeline is concerned. Also, aerial helicopter surveys are undertaken by officials to ensure that there is no unauthorized excavation, digging, or any such thing that is, or any unauthorized construction that's happening on top of the location where the pipeline is, so that it doesn't damage the pipeline in any way. It could happen that somebody is not aware that the pipeline is laid, they may start digging and they may hit the pipeline, and it can be fractured. It is quite possible, and if that happens, it can prove to be a big disaster. So. Usually officials carry out timely inspections to ensure that no such activity happens. Underwater pipelines, they are again monitored by battery operated vehicles, small submarines that go along the length of the pipeline to monitor the surface of the pipeline. And as I said, public education and communication is the absolute essential thing, because it is important to sensitize the locals about what's happening around them. Facility security and leak detection. This is again taking it to another level where some pipelines have independent leak detection systems. It could be through various ways. One of the options that I told you was through the battery operated ones. It could also be due to it can be acoustic measuring systems, etc. as well. And again, before granting license to operate a CCS plant, a set of emergency plans are laid down, which are reviewed by the regulatory authorities before granting the license to operate a CCS pipeline. The table that we see in front of you is a methodology that's developed by the Intergovernmental Panel on Climate Change, IPCC, and it is a methodology for future monitoring, verification and reporting as far as CCS projects are concerned. Again, going into a little more depth on this, the first point talks about site characterization, where they say that the project proponent has to confirm that the geology or storage site has been evaluated and that local and regional hydrogeology and leakage pathways have been identified. Which means that before you start out on a CCS project, the site that you have identified should have been thoroughly evaluated and the findings have to be reported. Secondly, assessment of rise of leakage. IPCC says the proponent has to confirm that the potential leakage has been evaluated through a combination of site characterization and realistic models. Again, where they say based on site characterization and realistic models, they are saying you have to predict the movement of the carbon dioxide over time in locations and identify possible locations where leakages or emissions of carbon dioxide might occur from the storage cells. Monitoring. This is to ensure that an adequate monitoring plan is in place, and reporting. It is also the proponent is required to report the amount of carbon dioxide that's injected at all points of time and any emissions from any of the points in the storage site. This is to ensure that a robust monitoring verification system is in place and there isn't any chance of leakage. And if any leakage is identified, it can be arrested or measures can be taken immediately. We then discussed about vessels, as somebody rightly pointed out, as for carbon dioxide transportation. This technology, as of now, is at a very, very nascent stage. And again, what happens is to take the carbon dioxide from the source, say a power plant or a steam plant, to the dock, you require tankers for this purpose. And again, these tankers can be similar to your hydrocarbon carriers. The thing is, the ships have to be customized and specifically built for holding this carbon dioxide. And again, as of now,